comes. Subject physics, light, that is optics. Topic today is refraction through spherical lenses. I am Veerabhadraya Demaya, retired geoanalytical marine chemist, Geological Survey of India, Kalyan Nagar, Bangalore. Today I would like to have a brief introduction to the spherical mirrors and spherical lenses comes in the optics. Optics are the special branch of physics which deals with the study of optical instruments, lenses, mirrors, etc. So here, sphere, it is a circular object available and the circle also. A sphere is a perfectly round geometrical object in three-dimensional space, 3D, that is the surface of the completely round ball. Like a circle in two-dimensional space, 2D, a sphere is defined mathematically as the set of points that are all the same distance r of the points. See here, this is a sphere, this is the center of the circle, this is the radius, and this is the two sphere, the three sphere is very important. Lenses. A lens is a transmissive optical device that focuses or disperses a light beam by means of refraction. A simple lens consists of a single piece of transparent material, while a compound lens consists of several simple lenses elements usually arranged along a common axis. Lenses are made from the materials such as glass or plastic and are ground and polished or molded to a desired shape. A lens can focus light to form an image, unlike a prism which refracts light without focusing. Devices that similarly focus or disperse waves and radiation other than visible light are also called lenses. Such as microwave lenses, electron lenses, acoustic lenses, or explosive lenses. So purpose of optical devices, the purpose of any optical device is so-called collect and gather light. These are the optical instruments, microscopes and telescopes. Well friends, lenses, convex lens and concave lens are the important two different types of lenses which acts as a predominant role in optics and the optical instruments. Concave lens and convex lens. Convex lens is called a positive or a converging lens, and the concave lens is a negative or a diverging lens. So this is the important information about the convex and concave lens. Difference between a convex lens and a concave lenses, A convex lens is a thick in the middle and thin at the edges, thick in the middle and thin at the edges. It's converging lens in nature, and a convex lens has a real focus. It is used for correction of hypermetropia and presbyopia, or the problems of the eye, which can be corrected using convex lens. It is used in the optical instruments, spectacles you can say. Concave lens is thin in the middle. It's quite opposite, thin in the middle and thick in the edges, thick at the edges. It is diverging in nature. This is diverging in nature. A concave lens has a virtual image. It is used for correction of myopia. So, what is converging lens or what is convex lens? A double convex lens or a converging lens focuses the diverging or a blurred light rays from a distant object by refracting or bending the rays twice. This double bending causes the rays to converge at a focal point behind the lens so that a sharper image can be seen or photographed. A positive focal length means that the focal point of the lens is on the other side of the lens from where the object is placed. So this is very important aspects of the convex lens. This is the parallel rays and it converging at a single point. This is called focal point, my dear friends. This is the focal point. Now we see. This is how this is the focal point it occurs. You see, the parallel rays are passing through the lens. Then this is which is converging at the point. See, this is converging at the point. As I told you, the convex lens is made up of glass or plastic, high quality plastic materials, which is used in the optical instruments, my dear friends. This is principal focus, the converging. All the rays are converging at a single point is called principal focus. So this is a camera lens forms a real image of a distant object. This is the distant object and the real image is inverted. This is principal focal length. This is focal length f1 and this is f2. This is 2f distance s1 and s2. Similarly, this is the object placed in between optic center. This is the optic center of the lens and 2f1. Then the image is formed behind the 2f1 at the same side of the lens. We will discuss later. Image formation by a convex lens. There are 6 possibilities of position of object in case of convex lens. One is object at infinity, object beyond center of curvature, object at center of curvature, object between center of curvature C and principal focus F, optical at object at the principal focus F, and the object between principal focus F and optical center. Well friends, convex lens convert parallel rays coming from the object at infinity and highly diminished point sized real and inverted images formed at principal focus F2. You see here, this is a very important figure, the object at infinity. These are the parallel rays coming from infinity and it is all the rays are passing through principal focus F2 and the image at F2 only it will form. The properties of the image is highly diminished, real and inverted. Object beyond center of curvature C1 and C2, that is C1 or 2f1. This is figure is concerned object beyond 2f, the image between f2 and 2f2. This is the image. The property of the image is diminished, real, and it is inverted, diminished, inverted, and it is real. Here the object is placed at exactly 2f1 and 2 rays are passing through. One is at f2 principal focus and another is optic center. They meet at the particular point 2f2. So this is the real, as the image is real and inverted as the same size of the object. Now here the object is placed between f1 and 2f1, then one ray is passed through principal focus and another ray is passed through optic center. They intersect, they form beyond 2f2. The image is formed beyond 2f2. It is inverted and it is enlarged and it is a real image. Now its object is placed at exactly f1 principal focus and one ray is passed through f2 as usual and another ray is passed through the optic center of the lens and it is there parallel. The nature of the image at infinity. Image is highly enlarged, real and inverted. A virtual erect and enlarged image is formed when the object is placed in between optic center and F1. So it is not at all meeting, it is diverting, and if you back produce the lines, then you will get a image is this one. The image is enlarged, virtual and erect. This is the important things to remember. Well friends, this is the compendium of all this convex lens, how it acts during the refraction. So this is a very important thing, converging lens, principal focus and all. Like, share, subscribe. Veerbhadraya Demaya. Contact 966 38